Thank you all for joining us this afternoon. This presentation is going to be recorded as a live webinar, so at the end of the presentation, please make sure you speak clearly into the mic if you're going to ask any questions. I would now like to introduce Randall Poston, Chair of ACI Committee 318, to deliver today's presentation and webinar.
Okay, thank you. Well, it's my pleasure to be here today to talk about what we've been doing for the last 10 years on Committee 318. Specifically, today I'm going to talk about the benefits, rationale, and availability of the what's been referred to as the Reorganized Code. I'm doing this on behalf of Committee 318 and pleased to be able to make this presentation. And we will have an opportunity at the end to ask questions and get some input from you in the audience. So during this presentation, you'll see some use of reference to 318.11, which is the existing code, and then also 318.14. 318.11 is will be shown in red, and 318.14 is in green, just to give you an idea when we compare and contrast some of the existing portions of the code and provisions and so forth. So this afternoon, the goal is to provide a brief history of ACI Committee 318 and specifically the building code requirements for structural concrete. What was the rationale? Why did we do this? Why would we undertake such a reorganization? I would like to describe how we've reorganized the 318 building code and the style and some of the things that we've made use of to try to improve the usability of the code, and then also to talk to you a little bit about the resources and access process timetable that we have, and how you'll be able to link into some things, resources that ACI is going to present for the code. So first, a little bit of a brief history of ACI Committee 318. The committee, the American Concrete Institute was originally formed as an association of the National Association of Cement Users. Back in 1904, there was an engineering congress at the St. Louis World's Fair, and they established that particular group. Now the American Concrete Institute, of course, located in a suburb of Detroit, Michigan, Farmington Hills, and this is the headquarters building. Please note that it's made of concrete. One of the we often refer to ACI as the American Concrete Institute. You certainly, that's its roots, where we were founded, but certainly where it's ended up, a lot of the standards, a lot of the traditions that it started at in ACI are now really worldwide. In fact, the building code, or portions of the building code, 318, are in fact used in 23 different countries at this time. So it truly has an international extent in terms of its use and its applicability. The first code was published in 1910, again by the National Association of Cement Users. It was called the Standard Building Code Regulations for the Use of Reinforced Concrete. Up until 1956, most of the provisions in the code made use of what we have referred to as working stress design methods and empirical-based methods through that time. And then in 1963 was the first use of, they had both working stress design and ultimate strength design. Ultimate strength became working stress was dropped in the 1971 code. The working stress design was dropped in the 1971 code, and ultimate strength became the de rigueur for the design of concrete, and has remained that way since 1971. The organization for the 318 has largely been based on behavior and design of in-place reinforced concrete through that time. Of course, we've added other methods such as precast and pre-stress, and we'll see how we integrate those into the new reorganized code shortly. Since 1971, as we develop, we do research, we learn from experience, we learn from research and practice. A lot of different things have come about that we need to have in design. These include things like development links, torsional strength, seismic design, and detailing. Of course, after the 1971 San Fernando earthquake, there were a lot of problems with with some of the detailing and performance of reinforced concrete, and so the committee spent a long time developing new and improved procedures for seismic design and detailing. Things like integrity and reinforcement to try to mitigate progressive collapse in an unusual event. Concrete exposure classes for durability. What is referred to as strain-based methods for strength reduction factors, so that our phi factors and for strength reduction change as we, depending on the strains of the concrete and or steel, and then also anchoring to concrete. So there's been a lot of changes, and again, that's all been added into the code since the 1971 code, and largely the format and the organization of the code has been remained unchanged since that time. So we're now some 40, almost 45 years later, and we have been dealing with that same organization through the 2011 code. So in 1971, the first year of the pure ultimate strength alone in the code, we had about 750 provisions. 2011, because of this research, because of what we've learned in practice, the code has grown to something more than 2,500 provisions. So you can see that it's increased in size, it's increased in thickness. Of course, that's something we've gotten a lot of complaints about over the years, and we're hopefully going in discussions today, you'll see how we've improved the usability of that. But, length and thickness is not everything. We have learned a lot. We need to take care of what's being used in practice. We need to take care of new construction methods and how people are actually using the code and building with the code. And so thus we're stuck with the idea that we're going to have more provisions. We just need to make it easier to use. So this is Committee 318, and you can see we're hard at work around the table. This particular code cycle, we've had 41 main committee members and some 30 subcommittee-only members. Gosh, I didn't know they had a picture. There's the chair of the committee, apparently. There's an unnamed structural engineer and an unnamed building official on the committee, and there's an unnamed materials engineer and a unnamed university researcher or academician. So you can see that we have kind of a broad cross-section of people that are on the code, and of course that's one way that we know that we have a truly consensus-based code when you marry the folks from down to the construction, the use of materials, all the way up to the structural designers and the academicians. Give you a little bit about how the rationale for reorganization. So since 1971, the code has principally been kind of the guts of it, if you will, are in Chapter 7 and 12, and those are really central, to the overall use of the code and the design of members. We have included in those chapters are things related to serviceability, things like crack control, things like deflection, and so forth. And then we calculate ultimate strength, Chapter 10. Chapter 11 has been shear, so it's really about the behavior and the design for those particular types of potential failure mechanisms. And then we have various related reinforcement details. So Chapter 7 to 12 are really central to this organization of the existing 2011 code. So if you look at, this is a detail of a column intersection beam and slab. In this particular detail, you can see right now we have to, in order to evaluate the flexural strength and axial load strength of that column, it's in Chapter 10. You need to, for the detailing of ties in the joint, you have to go to Chapter 11 because that relates to shear. For the shear strength of the column itself, that's in Chapter 11. Lap splices, which you, of course, are going to have throughout as you're building, you're constructing your building, are contained in Chapter 12. There's some additional detailing in the reinforcement in Chapter 7, and the cover requirements are in Chapter 7 as well. So you can see we have 5 different chapters for this particular detail that we have to use. You have to know what details are really specific for, or what provisions are specific to that detail, and you also have to know where they are located. So quite a challenge. Seasoned users, it's a little easier to understand where you need to go and understand all these provisions, but certainly as a new user or a casual user, it makes it a little more difficult not only to know what provisions you need, but where to go find them. Then what we have referred to kind of the specialty chapters in the existing 2011 code, things like two-way slabs, foundations, footings, precast concrete, pre-stressed concrete, seismic are all treated separately. So we have these core chapters 7 through 12, and then these specialty chapters, as we refer to them, that cover these other items. So we have a mix of designing for behavior, flexure, shear, axial loads, and then specialty chapters actually designing members like foundations and footings, and then specialty things in terms of structural concrete with pre-stressing and precast, and then design for seismic. So it's a blend of behavior-based and kind of member-based design, if you will, for the 2011 code. I'm going to use this as this is not meant to be a reflection of anything about the past Committee 318s, but if you had this, if this was your tool shed, and when you first moved in, it was all nice and neat, and you started adding stuff to that over the years, for 30 years, 40 years, you know where everything's at in that tool shed, right? You've been placing things here, placing things there, and you know where to go find it. But how if you have to tell somebody where you're going to go find that hammer, what are you going to do? Well, it's going to be a little bit difficult maybe to tell that individual where your hammer is in that tool shed. It's not disorganized, it's just that you know where it's at, but maybe not everybody else does. So this is a nice kind of analog for what we're doing with reorganization. So, we didn't undertake this as a committee very lightly. We started in the previous code cycle under Chair Jim White, looking at the idea of reorganization, simplification, and a number of different other concepts, and seeing, is there something that we want to do? Is there something that we need to do to improve the usability? In 2006, we got a little more serious. We did various focus groups with structural engineers around the country. We held workshops that with the committee in order to see what kind of focus do we want to have, where do we want to go, what kind of format or platform would we want to use for 318 if we were going to make a change. So in 2007, a year later, we kind of developed an outline and processed it a little further, and then in 2008, at the start of this code cycle, we decided this is going to be what we're going to do, and the committee signed off on it, and we began our way. So for the last 6 years, we've been working on this reorganized code and this platform of reorganization that I will be discussing a little bit more in more detail of what it is. So all of this is really about improving the usability of the code for the end user, whether it's principally for the licensed design professional, but certainly it has to be understood by the contractors and understood by inspectors as well. We want to make the information more easily found in terms of its logical positioning within individual chapters. One of the things that we really wanted to make sure, and that we heard very clearly through some of these focus groups, was that engineers never knew when the design was finished. They would design a beam, for an example. They do everything they needed to know, and get down to the end, and there were provisions that they didn't know about and didn't know that existed. And there was a little bit of, as an antidote, we found out about that. There were some trial designs that were evaluated by the Institute and very well-known designers, and in all cases, those very seasoned designers left out various provisions that they should have been using for the design. And so it's easy for anybody, seasoned user, whatever, to know when have they really completed their design of a particular member. So it's a very important point. And then I say clean the garage, and what do we mean by that? We wanted to shuffle things up and put them back together in a more logical fashion. So back to that analogy that we had of the shed or your garage. You know, we took everything out of the garage, and we started with a fresh slate for the code. There was essentially no provisions that had, when we started this process, no provisions had been adopted by the code when we started this. It was a clean slate. But we had to bring all the provisions that we had. We're not trying to change the provisions that are in the 2000 code. We're just trying to bring them back into a logical place where they're making a more usable code format. So this is what we think what we're trying to do. Organize everything into neat stacks and neat blocks. And we do, one of the things you want to notice, we have actually extra room to provide room for another sports car in there. So the idea is, as knowledge is gained, and as we do additional research and experience and practice, we will have the platform in which to be able to add to that more easily. And for the end user, they'll understand where that information is instead of trying to have to go find it every time. So that's the overall global concept, and I think it's a good analog for what we've done with reorganization. Okay, next, let's look at how 3.18.14 is organized. So everybody knows the 2011 code and format. Everything is more or less in terms of the platform has been the same since the 1971 code. So we have 6 major kind of building blocks that will show of how we put all that information back together. So we've stacked it, we believe, into a logical sequence. And one of the things that we kind of mirror that's not often talked about is how an actual project is designed and built. And it kind of follows the chronology, at least the organization of the code follows that chronology as well. So these are the building blocks for this new 2014 reorganized code. So the first section, as you would expect, is some general section where we got to introduce what the code does, how it relates to the general building code, the applicability for other types of non-building structures and so forth, and also about the language that's used, what is meant by the language, how we are instructing. It's of course written in legal language and shalls and so forth. So we've got to explain that kind of wording and that definition in terms of how we use it in the code. Next, we're going to have a platform of what we call systems. After that, members. After that, joints and connections. And then finally what we're calling toolbox chapters or utility chapters, which really are chapters that all of the members are going to make use of. You have to calculate something, you go to the toolbox chapter, and you return to your design of your member. And I'll explain that a little bit more detail, how that actually works. So, general chapters. Scope, application, interpretation. So we're letting the user, we're letting the building official, we're letting everybody who may use this code understand what the scope of the code is, what its applicability is to various systems, and how you would make interpretations based on the language and the format of the code. One of the things that we get often asked that's in Chapter 1 is if you have a special system or you have a special construction technique that is outside of what may be traditionally mainstream, and there's a question about it, Chapter 1 is where you go, and specifically, it used to be, I believe, Section 1.8 in the new code. You always have the ability to demonstrate to the building official that we've done research, this is applicable, and so even though it may be outside the code, it's still within the code because if it's approved by the building official. So there's a number of ways that even though the code may not directly address a situation, you may be able to extend your technique into construction. We have Chapter 2 is the same as we've had, notation and terminology. The next chapter 3, relative to standards, what kind of materials are allowed. This is where we generally refer to ASTM standards, for example, which ones are applicable and so forth. Chapter 4 on concrete design properties, and 5 is steel design properties. Now, let me go back to the concrete design properties. Since this is these are the properties that you're going to need at the beginning of a design process, things like what's your F'(C), what's your exposure class, and those sort of things. You need that as kind of your background base information before you get into the design of individual members and your type of structures. Same with steel design properties. Generally, grade 60 ASTM, but there are certain types of steel, for example, in seismic applications where, because of ductility requirements, then you have to use a different type of steel. So these are the parameters that you may need in order to start your the licensed design professional to start their design. Next building block. So we have those blocks. The next building block was systems. And then structural systems is a new chapter. One of the things that when we took the code apart and you're starting to put the pieces back together, you realize that it was always kind of there in the background, but was never really explicitly said in the building code. Is you're designing a building, you actually have to have a gravity load system, and you have to have a lateral load system. Most designers who've been working, of course, know that, but it never was explicitly stated. So this particular chapter tries to outlay the parameters that are used in building design, things that need to be considered in terms of the performance of the building and the behavior of the building. Some of the other chapters that you have to know about loads, you have to know about seismic detailing for lateral loads, or wind detailing if you have wind loads, walls, columns, beams, and so forth. And those are all in different chapters. But this new chapter, chapter 4, really kind of combines that and says, okay, this is the construct of what you're going to be doing for the design of your building. So we think this is a new, exciting change, and will put more definition into the building code. The loads and loads combinations is, of course, you need in order to start the design. There really hasn't been any change in that information per se in this reorganized codes. That's mostly the same. Structural analysis, what we did was bring all of the various types of analysis techniques that have kind of existed in the previous codes and pulled them into one location. Mostly those haven't changed, but one thing we have done and recognized, unfortunately maybe perhaps a little late, but that a lot of engineers are using finite element methods. This 2014 code makes explicit reference to finite element analysis techniques and what you need to be able to demonstrate using that method. So for the first time, it's considered in this chapter. Earthquake resistant structures is largely, there's been, because of behavior of buildings in some earthquakes, specifically the Chilean earthquake that occurred about 4 or 5 years ago, there's some new things that are happening in that chapter, but that chapter on seismic resistant structures has largely remained the same. And one of the things we had to decide when we want to make reference to right now, when we're looking at the design of members, a lot of folks said, well, why didn't you just include seismic in the design of those members? And we thought about that for a long time. The seismic chapter has, the old chapter 19, has undergone a lot of changes over the years, and I think the end users were getting tired of having to try to keep up with all the changes, and so we decided, let's give them a little bit of relief. Let's keep seismic separate. Let's keep it as a separate chapter for now. One of these days, maybe it'll be integrated into the individual member design, but a lot of reasons for keeping it separate, and the committee agreed that that's what we would do. Okay, so let's get to what I refer to maybe as the heart of the new reorganized codes, and that's member-based design. So member chapters would be things like we design one-way slabs. The slabs carry load over to beams, That load is then transferred from beams to columns. That load is then transferred down to foundations. And so there's a logical kind of sequencing of how we laid out the member-based design chapters. One of the new and plain concrete members is, of course, we've allowed that in the code, and we're still going to continue to allow that in the code, and we consider plain concrete almost as a member type, if you will, and they'll still be able to be used with the same sorts of requirements and limitations that have existed in the 2011 and previous codes. One new chapter is called diaphragms. When we were putting this information back together, it became clear, particularly with that Chapter 4, and you saw how lateral loads particularly were placed on a building. We talk about slabs, which are really gravity load slabs. In the seismic chapter, we talk about having collectors and diaphragms, but we really didn't have a chapter on, if you will, just diaphragm design and detailing. So that is a new chapter in this code. Will be a chapter on the design of diaphragms. So let's take an example. Chapter 10 is columns, and see how it's laid out. We've got a section 10.1 on scope. So what is the scope of this particular chapter? Well, it's column design. There's other wording that goes around with it and other generic descriptions, but basically it provides the limit of what this chapter and the applicability of these provisions in Chapter 10 to the code. Next, a general section, and the general section has things like the overall where it relates to member design as it relates to the overall building, other general provisions that may be applicable to all columns, and so forth. So it's a section where we just kind of collect miscellaneous information that is generic, if you will, to all columns. Design limits. Well, there are certain things in column designs that you can do, width to depth ratios, minimum width and depth of columns in terms of design, and so forth. So that particular chapter describes the limits, pluses and minuses, minimums and maximums that you can use in column design. Then we talk about the required strength of a column, which is what we're generally used to in providing the loads from loads and load combinations from your analysis. And then the design strength, you've got to make sure that your design strength exceeds your required strength, of course, with the appropriate fee factors. And so that particular section, 10.5, the design strength, describes for an individual member that strength and the calculation of that strength for making sure you exceed the required strength. And then the next section is on reinforcement limits. So there may be certain in columns, whether you have to have minimums 2% or 8%, and other limits that may be applicable in beams, the minimum reinforcement ratios, the maximum reinforcement ratios, and so forth. So it depends on the member type, but we have it spelled out in section 10.6. Then finally, when you get down to the bottom after calculating strength and those sorts of limits, you got to have their detailing requirements. You got to have certain bond length, development length. You got to have certain splice lengths and so forth. So all the detailing requirements for an individual member are located in this particular section, 10.7. So that's Chapter 10. Now we're going to go give another example and like to see what you think. Chapter 9 is beams. So in Chapter 9 in beams, what do you think how is it going to flow in Chapter 9? You think it, with reorganization, usability of the code, what would you expect that chapter to be? Well, 9.1 is scope. 9.2 is general. 9.3 through 9.7 are exactly the same for that member type. All member types, no matter what member you're designing, are going to have the same sections. And so whether you're designing a beam, designing a wall, designing a column, you should understand where that information would be relative to that particular topic. I think that's a pretty big advancement in terms of usability of the code, quickness of where you might find information for the member. So all of the design information that you need is going to be in that chapter. So let's go back to the detail, our detail that we looked at before, where we had 5 different chapters. You had to know which provisions were really applicable to that particular detail first. So you have to know that a priori, so you have to go find those, and then you have to use them, but then you're not even really sure you've gotten all the provisions that you needed in the first place. So we perform a little magic. And voila, here are all the provisions for columns, all in Chapter 10. So everything you need about that detail of that column design are now all in the same chapter. There's no mistaking it. I think that's a pretty exciting change, and not knowing, having to know where you're having to go for all these different provisions. Everything you need for the design of a column is in that chapter. Okay, so let's go next to, there's oddities in any kind of structural design, and joints and connections is a little bit of that one. Of course, beams intersect with columns in that region that's monolithic between the two. There are certain rules that have to govern the design of joints. In the context of this code, joints are kind of the monolithic construction. Connections are really referred to non-monolithic connections, for example, between precast members, and so that's kind of the distinction in the defining joints and connections in this particular code. So beam, column, slab column joints, any specific information that you may need in terms of the design and detailing of the joint region will be found in this chapter. The connections between members, and you can see laying out some precast members and the connectivity of those members, whether they be steel plates or whatever is referred to as a connection. The connection design strength is in this particular chapter. And then the other one, anchoring to concrete. You will be happy to know that Appendix D, which was for post-installed anchors, which has changed probably every code cycle since they've ever been introduced in a great way, has largely been left untouched. That has been the most anchors. Unfortunately, you get the least amount of money designing them, and you have to spend the most time designing them. We still are stuck with that, but we have moved it from the appendix into a chapter of the code, so I am going to tell you that. But largely, the post-installed anchors, and remember, 2011 was a big year for post-installed anchors, so we added all of the requirements for adhesive anchors in the 2011 code. But largely, the Appendix D, which is now in the main body of the code, is really remained largely untouched. So we were excited that we didn't have to do anything. Okay, next section, what we call toolbox or utility chapter. So we have all these the upfront stuff that you need for the design, all the stuff you need for your member designs, all those provisions. You get to joints and connections, which are the things kind of connection. These toolbox are things that are going to be used by all of the member design chapters. And these are things like strength reduction factors, sectional strength, plane strength, sections remain plane, and how do you design for flexure, strut and tie methods, serviceability, and reinforcement details. And so, one of the things that we get asked, well, not everything's in the same chapter. That's not exactly right. Everything in the chapter that you need is, in fact, in the chapter. What we're going to do is refer then where you need something like sectional strength of a beam. You go from your beam chapter over to sectional strength, make your computation, then go back to that beam chapter. If you need something about detail or about serviceability, you go over to this. It's going to refer you in a reference over to the toolbox chapter. You make that calculation, then you go back to that chapter. And the reason we did that is so we wouldn't have to duplicate all of that information in each of the member-based chapters. You can see there's a lot of common links between different member designs, but this way we wouldn't have to repeat all that information and greatly lengthen the code. So that was a decision. We had to decide what to do. That was a decision the committee made and said, you know, to try to limit the amount of additional information, although putting in the chapter might be easier. We didn't know. We felt like this toolbox or utility chapter was the best way, in fact, to go. So if we look at an example, here's the member chapter. This happens to be slabs or beams. If you look at the requirement here, it says if you're looking at the calculated strength is in accordance to 22.3, you're going to go over to 22.3, which is one of these utility chapters, calculate the moment strength, and then go back over here right to the next provision in terms of the design of your member. Same with here, this particular one where it's greater than 10% of the axial load, the requirement for the required strength has got to be greater than that calculated in accordance with chapter provision 22.4. Make the jump over to 22.4, make the calculation, go back to that provision and go to the next provision. So that's the logical sequencing, if you will, for the member design using these utility chapters and these toolbox chapters. Okay, the last section, construction. Also remember, I've been talking about this kind of more or less follows the chronology in terms of from the beginning of a project where you're setting the basis of design. You need certain design information. You design your do your analysis and loads. You design your members. You got to do certain things with respect to the connections and then or other post-installed anchors, and then you get to the construction. So it kind of follows at the end of the project. The construction requirements or provisions are, in fact, at the end of the towards the end of the code. So Chapter 26, construction documents and inspection. This is going to be big change. It's always been in the code about requirements, and they've always really been there for the engineer to address what information needs to be transmitted to the contractor in terms of the design. That was the premise. It was never really fully understood. Now it's going to be very uniquely understood that Chapter 26 is largely focused on the licensed design professional and what information he needs to give and provide to the contractor in terms of the contract documents, design drawings, and the specifications, so that the contractor knows, even though it's called construction documents and inspection. So it's that information that's critical for the construction process. So 318 is written to the engineer to be not the contractor. It's the information the engineer needs to transmit and relay to the contractor. All this information is collected and gathered, if you will, in what they're really construction documents, unique from contract documents. We feel like the technical part are really just the design drawings and specifications. Contract documents means there's a contract between, which is a legal thing between, say, an owner and the licensed design professional. We're not really covering that. This is the technical information that needs to be conveyed by the engineer in terms of the construction documents. So in 318.11, these construction requirements were interspersed throughout the code. They were, often located with some sort of design requirement, whether it be in related to flexure or something between the interface between members, and so they were interspersed throughout the code. And again, in terms of usability, what would be very useful to the user, particularly the licensed design professional in this case? Well, we believe that by collecting all that information that had been previously strewn out between all the chapters, put them in one place together in Chapter 26 would be the most useful thing. So in one chapter, we've taken all the requirements that need to be conveyed by the licensed design professional in the construction documents into one chapter. So again, we think this is a huge leap in terms of usability of the code. So again, red is for 318.11. You look at these provisions. This happens to be for construction joints. It's kind of a mix of some design. If you look at these provisions and read them, it's kind of a mix of design requirements plus requirements that you need in construction. And so it gets very convoluted as, okay, what information am I really needing to convey to the contractor related to construction joints? Plus we have construction joints in multiple different locations because of different requirements, whether it be for type of member or type of placement and so forth. So a little bit confusing. In the 14 code, when we look at, and this is still in, we were just finishing up on Chapter 26, and I'll tell you where we're at in the whole process, but joints and concrete, now in Chapter 26, we very clearly say the design information that you need to convey are locations to the contractor on the construction documents, locations and details of construction, isolation, and contraction joints. You need to relay what provisions for transfer of shear you need through this construction joint. What surface preparation requirements do you expect as a designer to include in the construction, into the joint? Is it intentional roughing? Is it something else? So it's very clear what information you need to convey to the contractor and the inspector in terms of the contract or the construction documents. Let's talk a little bit about some maybe less exciting things, but something that we think also helps improve the use and readability of the code, and that's kind of the style. We set a certain style, if you will. We tried to do a number of things that would improve the readability of the code and the usability of the code. So here's a provision in the 2011 code regarding center-to-center spacing. I defy you to read this, and let me give you a test after 10 minutes, and you can tell me what does it really mean after 10 minutes. And I still don't know if you could tell me. Center-to-center spacing of pre-tensioning tendons at each end of member shall not be less than 4 dB or 5 dB for wires, except that in specified compressive strength, and minimum center-to-center spacing 1 3/4 strands, half inch, da-da-da-da-da. I mean, see also 3.3.2. I mean, it's very convoluted. You got to sit there and read it and reread it, and you know, it takes me a little time to read these things. I have to sketch out something on the side of the piece of paper what it really means. So how could we improve what that really says in terms of requirement about center-to-center spacing of pre-stressing? Well, what about a table? So all that information that we just said, as engineers, we like to see something graphically, something easy. So instead of saying all those words, let's put it in a table. Now, if you look at that, I think that's a little easier to understand what the minimum center-to-center spacing of pre-tension strands is at the end of a member. If it's greater than or equal to 4,000 psi, and you have strand diameter it's less than a half inch or less, there's your answer. So we think that's a big improvement. So we've made a lot of use of tables throughout the code where you get to those types of provisions where, and they were easy to tell because they were multi-phrase sentences that try to explain what you're going to do and what the exceptions were all in one sentence. It's like, this is made for a table. Okay, and one of the things you may have noticed that we don't actually now have a chapter on pre-stressed concrete or precast concrete. Well, that's because we cover all of that information whether it be reinforced, conventionally reinforced, or pre-stressed concrete. If it's a beam, all that information, be it one or the other, is contained in that chapter. We don't have separate specialty chapters, if you will, for pre-stressed concrete. So in the old pre-stressed concrete, Chapter 18, everything related to Chapter 18 would be there. And because it was a specialty chapter, it didn't necessarily convey, or you had exceptions to what the rules were from, say, reinforced concrete design. You would get, this is one of my favorite provisions of all time. You do this, except as specifically noted in all these sections, and if it's 14.6, except that certain sections of 10.6 apply, as noted in 18.4.4.4. Again, I mean, you have to have a roadmap in order to figure out what does that provision actually say. It says a lot, and you got to make sure you check certain things and eliminate other things as exceptions. So it's a very complicated sort of wording provision. So in the 318.14 style, if you will, that we're trying to use, we have the requirements for, say, reinforcement limits, whether it be a non-pre-stressed member or a flexural requirements in a pre-stressed member. All in the same, they're all there in the chapter. Reinforcement detailing, section 9.7, same thing. All of the flexural reinforcement requirements and non-pre-stressed beams in one section, 9.73 for pre-stressed beams, all in the same section, 9.7.4. So I think you can understand a little bit in terms of the style. We're trying to simplify not only where things were located, but the style and use of provisions where we're translating information that has to be done. It's legal information. There was never anything that said that you couldn't use a table. We had some tables in the code, but we made much greater use of tables. We try to clear up by pulling things together into given chapters. The style and the readability, we believe, of the code will be much more usable in that fashion. So again, the usability of the code, the provisions have been organized from a designer's perspective. The code is really designed, is really for the licensed design professional. There is some things that certainly a contractor and inspectors and building officials need to understand, but it really is for the engineer and other licensed design professional. We believe another benefit is where to find specific requirements. You think of the example of where that beam or that column detail versus from the 2011 to the 2014, having all of the requirements in one chapter versus scattered throughout various provisions of the code. Intuitive location of the information. You saw the structure that we had for members. That structure and organization for each member type is exactly the same with the same section numbers. So we feel like it's much more intuitive for the user to know where to go find that information. By pulling all of this apart and putting it back together, we eliminated a huge amount of cross-referencing that we had to do in previous codes. In the 2011 code, as all those 2,500 provisions became organized throughout the code, when you needed to know something else, you had to refer back to this provision, which may refer back to another provision, and so forth. So by organizing it into this member-based structure and to these specific blocks that we have, we've been able to reduce significantly the cross-referencing that we're having to do to go outside. Again, we have to reference to the utility or toolbox chapters when we're in a member-based design, but that's only for member-based design and then going all the way back to requirements that you may need, such as sectional strength or shear strength, and then you go right back. So we've reduced the cross-referencing that is required by the organization that we've utilized. We believe that the tables are going to improve your understanding. Again, you read that provision versus looking graphically at that table. What does that table really tell you? It's a lot easier to understand, we believe, in a tabular format. One of the things we try to use consistent language throughout the code. Wherever we had, and particularly through the member-based chapters, where you see wording and provisions, they will look very parallel in sentence structure and grammar, if you will, through each of those chapters. So we've tried to make it, whether you're looking at a beam or a wall or whatever, it's very consistent in terms of language and style across those various member types. Also, and this is not universal, but we really did, because there's always an exception to the rule, but we really try to make it so that every provision was a single idea. And if you look at the 2011 code, some provisions, they will be multi-layered. They would actually have separations as in separate paragraphs. It's all under one provision, but it may go on for a half a page with multiple paragraphs which are relating to one provision, one line number in the code. So we really, wherever you see a provision number, it's really to express one idea. Okay. Let's talk a little bit about available resources and the timetable for where it's going to be at. And I know you're going to want to, as soon as it comes off the press, you're going to want to go out there and buy this thing. So we've got to tell you a little bit about the deliverables and when ACI is going to have it ready. So let's take a look at that. So most of our work, for the most part, ended at the last convention in Phoenix in 2013. The Chapter 26, admittedly, was the construction chapter. We actually had to work on and process it separately, but we had sent the document off, except for Chapter 26, to the TAC, which is the Technical Activities Committee, a group of 12 people that reviews all documents within ACI back in December. We did that right near the holidays, just hoping that they wouldn't really take a hard look at it, but we weren't so lucky. We got a lot of comments. And good comments. And so in February, we got the word. We had a review with the TAC chair and the review chief for the document, and we were given lots of primary comments in which we had to respond to. So everything that was all done, and the subcommittees and committee have been working on responding to those TAC comments. And that's all part of the consensus-based process, and so we've been doing that at this convention. Chapter 26 was a little bit behind, but we actually got it to TAC a little bit later. They were good enough to review it, and we actually got comments back at this meeting, and we're processing response to those comments at this meeting as well. So when we leave this meeting, we will have presumably answered all of TAC's questions. They will get back with us and say, yes, you responded to those questions, and then the next process is the public comment period. And we're anticipating a May 1st date. It may be May 1st. It may be a little later, just depending how staff can take what we send back to them and get it put into a form to send out for public comment. So sometime in or near May 1st, you will be able to download the document. It won't be in two-column form. It will be code in one document and commentary in another document, and look at and we are going to be encouraging you to provide public comments to us. We're really interested in knowing what the users in the construction community think about this document. After we get those public comment, that will be for a 45-day period. That's part of the standardization process. After 45 days, headquarters will collect all those public comments, and then they will transmit them back to Committee 318, and then we've got to respond to those comments. And we fully expect, a lot of comments, given the nature of how different this code's going to look, and we fully expect that no one's perfect. We're going to find errors in it and things that maybe cross-references that aren't correct, or references that aren't correct, and those sort of things. And we will certainly take care of those. We will respond to those comments this summer, and then we're having a special Committee 318 meeting in August to basically ballot those response to public comments and then transmit that back to headquarters. I believe TAC takes a look at those to make sure we've adequately responded, but shortly at the end of the summer, headquarters will be sending this, well, they'll be doing that before then, but they'll be in active mode of putting it in layout for publication, and we would expect publication sometime around October or so in this fall. So it will have been printed, and it needed to be done by December 1st, which was the deadline for it to be incorporated into the 2015 International Building Code, IBC. So we expect a little bit of breathing room, so to speak, but not a whole lot. The document is going to be published in English, Spanish, Chinese. It's going to be published in U.S. customary units and SI units, and it's going to be available in a variety of formats, including the printed copy, of course, hard copy, enhanced PDF, which has been available and is going to be expanded, though, in terms of its capability, and then in various types of e-publication formats, EPUB, MOBI, that sort of thing. We've actually had a task group that's looked at these formats and what we can do to improve, because we know people are using digital tablets and iPhones. The enhanced PDF, for example, you'll be able to bring it up on the phone if you need to out in the field and be able to flip through pages very quickly. And so we know that that's the way the industry is going, the way younger folks are using code and really in tuned electronic formats. And so we're trying to address those in a variety of these enhanced electronic formats. There's going to be, one of the things we've been asked is well, I know where everything is in the 2011 code, where's it in the 2014 code. We're going to provide online transition key maps. So if there's something that, for whatever reason, that was in 2011, you want to know where it ended up, at least in part or in whole, we will have maps from 2011 to 2014 and vice versa. The Reinforced Concrete Design Manual that's done by committee, the design manual that's been around for many years is going to be consistent with the 318.14 format. So that's going to be done very quickly. And then obviously we're going to have a lot, because of the nature of this, there's going to be a lot of online learning opportunities, a lot of in-person seminars. There will be things both, I think, in various cities. But again, one of the things, if you can't, you can't get out to a convention or you can't get out to a seminar, I think we're going to have plenty of opportunities for you to do some learning, electronic learning online, so that you understand some of the more than what we're just presenting here today. This is just an overview, and you've got to be able to, of course, use the code, and we want to make sure you know how to do that. You can go right now to concrete.org/ACI318. We have a sample chapter. We have other information that you can look at that is available, a little bit more detail about the presentation that I've made today. Again, we ask you to review the code. If you have any comments, and to send those in, we'd really love to hear from you. For those that are I don't know, what, under 35 maybe. We've got electronic formats for you, both on Twitter and Facebook. Otherwise, we of course will have hard copies, but in all seriousness, we've really tried to engage through electronic media, these various types of things, so that you can look at what we're doing and respond accordingly. So we have electronic connections at Twitter and Facebook. One of the things that people asked, and I finally sat down and calculated what it took to reorganize this code. And again, we've really been working on it for over 10 years with, a lot of vigor and rigor over the last 6 years in this code cycle. By all rights, we should have already been done. This should have been the start of the next code committee, but we're still finishing up. It was calculated something like 96,000 man hours or 46 man years of effort, and if you put some reasonable dollar figure for for various types of construction, design, and building official hourly rates or whatever, you're talking about something like $14 million in volunteer time to produce this reorganized code. So it's it was quite an undertaking, and I'm very proud of all our committee members. They've done an exceptional job. This was a task that I don't think anybody thought we could really get done and get concluded, but there is light at the end of the tunnel. I haven't taken much of a deep breath yet, but I'm just about there, and we're excited to present this to the community, and we're looking forward to your comments. Thank you very much. I'll be glad to answer any questions at this time. Thank you.
I'll be the first one to ask the question because as a professor we taught a number of years. But the major thing that bothers me in the last 1 hour that I listened to you, Randy, is when are we going to 750 to 2500? Are we back to some very beginning?
In terms of the number of provisions and the page length, it's probably going to be pretty comparable, because what we really did not add, we added a chapter 4 on structural systems, and we added a chapter on diaphragms, but we found out when we pulled all this apart, there were many provisions that were exactly the same in different parts of the code. They were the same, it was the same provision, and no one ever knew that. Literally the same provision. So we actually had, because of this separating out, filling in the gaps and redundancies, we were able to eliminate some information, but largely the 2014 code is it's reorganized, but it's the same content as the 2011.
The same direction is some 30 years ago when we went from 2 to 1 code and commentary.
Yes.
All together. We didn't like it in the beginning, and we got used to it. Now we're going back to the other direction.
No, code and commentary will be side by side.
I thought you said it would be not 2 columns.
No. Only the version that comes out for public comment only. Because it's not in publication format yet, it's basically a PDF that will be sent, that will be available for download just as for public comment period. But the actual printing that's done finally will be side-by-side format. I'm sorry I didn't clarify that, but yeah, we're not changing that format, same side-by-side format as we've always had.
Pages we had.
It's going to be, Mike, what do you think? I don't know. It's going to be about the same. It's really not going to change much. Let's put it that. Actually, we're going to use thinner paper to make it thinner.
I heard about chapter 4 has been changed. Where are the old chapter 4 and chapter 5?
You're talking about materials? Yeah, so they essentially it's all of that material is kind of in probably 2 chapters. It's still the information such as F prime C and information such as the exposure class, which you need for the design, is up front, and then the information that's needed in terms of the material requirements for how we design, mixed design for strength and whatever is in, I think it's chapter 18 or chapter, I can't remember the chapter, but it's kind of pulled out in terms of information that's needed for design and information that's needed for construction, if you will. So, but the same information is the same there. Yes?
I have a question on the technical changes. I mean, I understand
yeah.
the restructuring. I'd like to know the point 004, which is, as an educator, I find it a useless thing to teach new generations. And I understand the rationale of that. I'd like to know from you if this is going to be staying in this code, and if there is any plan for the future to remove that part.
Well, the .04 for now is the same, and we have not changed that. There is some thought about changing it. I think that is definitely something that the next code committee is looking at. I don't know what the direction is, but there is some thought about changing it.
Any other technical changes or just research?
No, we do have some other technical changes. Again, I wouldn't say necessarily changes, they're technical additions. This Chapter 4 on structural systems is a new chapter, which had not been in the code. Of course, it's technical information, but more or less lays out the foundations for design. That's a new change, and then that chapter on diaphragms is a new chapter. It's specific requirements about diaphragms, so that's new. And then there's some modest changes throughout. Not very intensive, but a few changes that have come up that we needed to process and that we are interspersing, but not in terms of technical changes, not as much as you might see in a typical code cycle. You're welcome. I'm sorry, in a smaller format, hard copy format? Yeah, so we have we've kept with the traditional 8.5 by 11 hard copy format. You know, there have been some discussion in the past about having smaller things that have a more handbook type style, but it was very difficult from a layout point of view. So we've kept hard copy wise. If you want to reduce the size and carry it around, you got to put it on your phone.
Can you speak about the acceptance of the new ACI 31814 into local building codes?
Into the?
Into local building codes?
Well, yes, I can. So every state and every jurisdiction, or most jurisdictions in the United States, municipalities have a building code. A lot of states adopt the state building code, and a local municipality will adopt that state building code. And the state building codes generally adopt what's referred to as the model IBC code, the International Building Code. And so IBC is probably the largest code that's adopted by as legal documents for design. Those explicitly reference the 31814 building code. There may be some municipalities, for example, cities of Chicago and New York have their own building code. They largely take things from 318, but whether they adopt it or not, it's unclear.
Okay, and then another one was, can you speak about the acceptance of the new code within the provisions of major design software programs?
Yeah, I don't think there's really going to be much change in the software. We've really just unscrambled and re-scrambled the provisions, so the provisions in terms of the technical aspects of design are the same. We actually had on our major subcommittee that dealt with member design, a software developer, and so which was good interface with that community that develops software. So we don't really expect much change. Certainly not going to be transparent to the end user of software. Well, I want to thank you for your attention and appreciate listening this afternoon. And again, we're very hopeful about the document, and we're want to listen to you, and we'll appreciate any public comments.